Hey, welcome to lesson number 7. I'm going to do something a little bit different with the whiteboards this time around. Yeah, so I hope this works out. This is the first example we're going to look at, and for this lesson, and actually it's the only example that I'm going to do. So this is class example number 3. Everything before this is just kind of an individual investigation, and if it's something you need help with, just let me know in class, and I'll be happy to just walk you through what those investigations are about. But with this first example, we want to describe which transformations are applied to a graph of a function when the following changes are made to its equation. So does the order in which the transformations are performed affect the final graph? All right, so the first thing we want to do is replace x with 3x and y with y plus 4. All right, so this first one is going to be a horizontal stretch about the y-axis by a factor of 1/3, and then we're going to have a vertical translation of 4 units down. All right, so those are the two transformations that we're performing here. Now, if I can do 1, 2 in terms of order. So I could do my replacement with my x with 3x, and then I can do my replacement of y with 3y plus 4, or I can do the other way around where I do the replacement with y plus 4 first, and then I carry out this. So let's see what's going to happen when I do it the first way. So I have f of x, so y equals f of x, and I'm going to replace x with 3x, so f of 3x. And then I put my second replacement into there with this y with y plus 4. Y plus 4 is equal to f of 3x. And in order to balance this equation, I just bring that 4 to the other side. I end up with 3x minus 4. All right, so this would be my final answer. Now, another way I could approach this is if I do the vertical translation and then the horizontal stretch. And so y is equal to f of x. Sorry I didn't at the same point, but instead of doing 3x first, I'm going to go y plus 4 first is equal to f of x. If I balance out that equation, I have f of x minus 4. And then the second one I'm going to do is replace x with 3x, and so y is equal to f of 3x minus 4. And you'll see that in this situation, it didn't make a difference whether I did the replacement with x with 3x or y with y plus 4 first. I ended up with the same results in the end. But you'll see that there are times and there are scenarios where you do have to worry about the order in which you're doing your transformations. So the second one we're going to do is we're going to replace x with 2/3 x. We'll replace y, and this w with the slash just means with, y with negative 3y, and we're going to replace x with x plus 2. So what do we have going on here? Well, replace x with 2/3 x. That means we have a horizontal stretch about the y-axis by a factor of 3/2. Y with negative 3y, we have a vertical stretch about the x-axis by a factor of 1/3. And it's negative, which means we also have a reflection in the x-axis. And then lastly, we have we're replacing x with x plus 2, which means we have a horizontal translation 2 units to the left. So will order matter here? The first order we're going to do is we'll do 1, 2, and then we'll do 3. And then what we're going to do is we're going to do the backwards. We'll do 1, 2, and 3. All right, so instead of going down with my equation, I'm just going to go across just because I'll have more room on the video here. So we start off with the same thing, y equals f of x. And I'm going to be carrying out this transformation. The next thing I'm going to do is I'm going to replace x with 2/3 x. So I have x is equal to f of 2/3 x. Then I replace y with negative 3y. I have negative 3y is equal to f of 2/3 x. If I carry it on over here, if I balance out this equation, I'm going to end up with y is equal to negative 1/3 f of 2/3 x. Carrying on, the last transformation I got to do is that x plus 2, and I end up with my final answer being y is equal to negative 1/3 f of 2/3 x plus 2. All right, so this is my final answer if I do the transformations in the order of 1, 2, and 3. Now I'm going to do it the opposite way, and I'm starting out with my horizontal translation, with then my vertical stretch and reflection, and then my horizontal stretch. So let's see what we end up with, and I'm going to do that in green here. So y is equal to f of x. That's where we're starting. I'm going to start with my horizontal translation. So y is equal to f of x plus 2. Now I'm going to do the my vertical stretch. So negative 3y is equal to f of x plus 2. If I carry it on down here, I have y is equal to negative 1/3 by balancing out my equation, bringing that negative 3 to the other side, f of x plus 2. And then I have my the last one I need to perform, and I have to replace my x with 2/3 x. So I'll have y is equal to negative 1/3 f of 2/3 x plus 2. So if we look at what happened here and compare, and maybe I should circle this with this, if I were to simplify this equation in red, and I'll simplify it in red down here, just underneath my final equation, we're going to see that we get two different equations and two different lines. So I end up with 1/3 f, but if I have this 2/3 as a coefficient, I need to distribute it into my brackets here. And once I distribute it, I'm going to end up with 2/3 x, which is the same. So far so good. But 2/3 plus 2, or sorry, 2/3 times 2, we're going to end up with 4/3. Or sorry, we're going to end up with 3 once we simplify. And so you see here that the order in which we actually carry out our transformations does matter. And yeah, which means that for the most part, when you follow an order, or when you're carrying out transformations, you want to do it in the order of stretches, reflections, and then translations. All right, unless a question specifically tells you to do it a different way, make sure you translate in this way: stretches, reflections, translations.